Have you ever felt like you're just drowning in this sea of AI models? Every single one claims it's the best, the fastest, the smartest. So how do you separate the hype from what's actually real? Well, in this explainer, we're going to give you the essential guide for reading AI performance scores so you can make much smarter choices. Let's get right into it.
This quote, wow, it just hits the nail on the head, doesn't it? We get bombarded with these super impressive scores and leaderboards, but what do they really mean? You see, benchmarks are a really powerful tool, but they can also be a bit of a smokescreen. And if you don't know how to read them, you can get very, very misled.
This right here is the fundamental problem we're all dealing with, right? It doesn't matter if you're a developer, picking a model for your next app, or just someone curious about tech. It feels like every single week there's a new best model, and the claims, they're just overwhelming. So how do we cut through all that noise?
Okay, before we dive into the solution, let's just take a quick second to appreciate the sheer scale of the AI landscape today. It's not just a field anymore. It's a whole universe.
I mean, just think about it for a second. You've got these open source giants, you've got proprietary systems, there's an absolute flood of options out there. And every single one comes with its own marketing spin and its own performance charts. It makes doing a fair apples-to-apples comparison almost impossible. And that's exactly why this idea for a standardized solution even came about.
So how do we bring some kind of order to all this chaos? Well, the AI community came up with a pretty elegant solution, basically a standardized scorecard system. Let's break down how it works.
So a benchmark is, at its core, a standardized test for an AI. The best way to think about it is like the SATs for college applications. It's a way to create a level playing field so you can compare all these different models on a very specific set of tasks.
And this slide gives you a great little snapshot of the different kinds of benchmarks. For example, you've got MMLU, which tests a model's general knowledge. You can think of it like a giant trivia night for AI. Then you have something like HumanEval, which is all about coding. Can the AI actually write code that works? Then there are agent benchmarks like WebArena, which test if a model can, actually do things in a digital environment. And of course, super important, there are safety benchmarks to make sure the AI isn't spitting out harmful stuff. Each test measures a totally different skill.
But, and this is where we get to the really crucial part, this simple scorecard solution, it's not perfect. Actually, it has some pretty big flaws that you absolutely have to know about.
Let's go back to that SAT as analogy. A student can totally ace the test, right? But does that guarantee they'll be a brilliant innovator or a great team player in college? Not really. And the exact same thing is true for AI. A high benchmark score is a good sign, for sure, but it is far from the whole story. Let's get into why.
Okay, the first major problem is something called contamination. This is what happens when the answers to the test are accidentally included in the model's training data. It's basically the same as a student finding the answer key online and just memorizing it. The model isn't actually thinking or reasoning, it's just repeating back something it's already seen.
The second issue is called overfitting, which is pretty much teaching to the test. Models can be trained so heavily on one specific benchmark that they get amazing at that one test's format and question style, but then they completely fail to apply that skill to slightly different real-world problems. They've learned the test, not the actual skill underneath.
And this right here, this comparison just says it all, doesn't it? This illustrates the third problem, narrow scope. A model might get a perfect score on a multiple-choice science quiz. That's great. But that tells you almost nothing about its ability to handle a really nuanced real-world task like writing an empathetic email to a frustrated customer. Success on the benchmark just doesn't always translate.
Okay, so we've seen the problems with benchmarks, but that does not mean we should just throw them away. We just need to learn how to use them the right way. So here's a really practical framework for reading these AI scores correctly.
So here are 3 simple rules to live by. First, treat a high score as a promising signal, not the final verdict. It's a starting point, not the finish line. Second, you have to understand the test. If you need a creative writing partner, a high score on a coding benchmark means nothing for your goal. And third, and listen, this is the most important one, always, always verify. Test the model on your own tasks with your own data before you commit to anything.
So this brings us to what I think is the single most important takeaway from this whole explainer. If you're going to remember one thing, please make it this.
This is the mantra right here. Use benchmarks to guide your search, to help you narrow down the options from that massive ocean of models we talked about. But you have to let your real-world evaluations,
Your specific use cases, your data, be the thing that makes the final decision. That's how you pick the right tool for the job.
And that leaves us with a really fascinating question to think about for the future. Standardized tests work pretty well for facts and code, but how do you score something like creativity, or nuance, or empathy? As AI keeps getting more advanced, our ways of measuring it are going to have to evolve right along with it. Definitely something to think about. Thanks for tuning in.